This is a short video on probability theory for coin tossing. Say that you toss a coin n times. So n would be once, 1 or 2 or 3 or 4, a natural number. And say that p sub h is the probability of a head on a single toss, and p sub t is the probability of a tail on a single toss. So clearly p sub h plus p sub t is going to be equal to 1. For example, if it was a fair coin, p sub h would be equal to 1/2, p sub t would be equal to 1/2, and 1/2 plus 1/2 would be equal to 1. Okay, under that scenario, then the probability of getting m heads, if you toss the coin n times, is n factorial divided by m factorial times n minus m factorial times the probability of getting a head on any single toss to the mth power times the probability of getting a tail on any single toss to the n minus mth power. Okay, so let's take an example. Let's say you flip the coin 3 times and that the coin is fair. And in that case, p sub h and p sub t would both be equal to 1/2. That's what a fair coin does. If you flip it, half the time on the average it comes up heads, half the time it comes up tails. So let's compute the probability of getting 3 heads, and the probability of getting 2 heads, and the probability of getting 1 head, and the probability of getting 0 heads. Probability of getting 3 heads using the formula is 3 factorial divided by 3 factorial times 3 minus 3 factorial. Okay, so this becomes 0 factorial, and one aside here is, by definition, 0 factorial is equal to 1, times 1/2 to the 3 times 1/2 to the 3 minus 3. 3 minus 3 is 0, so this is just 1. And so this part of it is 1/8, and the number multiplying it is 3 factorial divided by 3 factorial, since 0 factorial is 1. So it's 1 times 1/8, which is 1/8. The probability of getting 2 heads is 3 factorial divided by 2 factorial times 1 factorial. So this 1 came from 3 minus 2. 1/2 to the 2 times 1/2 to the 1, so that you would have 1/8 times 3, 3/8. Probability of getting 2 heads if you flip the coin 3 times is 3/8. Probability of getting 1 head is 3 factorial divided by 1 factorial, 2 factorial times 1/8, 1/2 times 1/2 times 1/2. And so that's going to be the same for a fair coin as the probability of getting 2 heads. And lastly, the probability of getting 0 heads is 3 factorial over 0 factorial, 3 factorial times 1/8, and that's going to be 1/8. So what you should note here is that the probability of getting 3 heads or 2 heads or 1 head or 0 heads, 1/8 plus 3/8 plus 3/8 plus 1/8 sums to 1. And just to repeat the significance of this is the probability of getting 3 heads or 2 heads or 1 head or 0 heads, which clearly has to sum to 1. And so the code that I have posted that you should check your simulated code against essentially just uses this formula. And there's many cases that you have to simulate in the project. You have to simulate coin tosses of 5, 10, 20, and 50, and you have to simulate fair coins where p sub h and p sub t are 1/2. But then you also have to simulate unfair coins where p sub h is 0.52 and 0.55 and the other values referred to in the project. And you can always use this formula, for which I have written and posted Python code to make predictions. So that explains the formula. It doesn't explain the theory behind the formula, but I think this is good enough to guide you and show you that you're doing the simulation correctly, because your simulations should be close to what is predicted by this code according to probability theory.